Jai Jinendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 48th question of the problem solving series, which is based on greedy algorithm. So this is the last question of the greedy algorithm in this playlist of mine. The difficulty level for this question is medium, and this question has been asked in Dell, Cisco, and Microsoft, and probably many other companies as well. So, fractional knapsack. This is a basic question of greedy algorithm. And we have another question called as 01 knapsack, which is a same question but slightly a difference, and that cannot be solved with greedy algorithm. For that question we need to solve it with dynamic programming. So here in this question we'll discuss what is fractional knapsack problem. Okay, so we have an item structure which contains weight and value. So here we have written in the example, we have written them individually. So we have objects, different objects, n number of objects which has different weights and its value is different. Okay, so if we are taking and we have a final weight, okay, that much weight our knapsack can hold. Okay, so suppose if in this example this one's weight is 10 and the value is 100. Okay, so what do we do in greedy? We go for the maximum, right? If we need maximum, we go for the maximum. We take that. In the first three questions of the greedy, in the previous three videos, we have seen we opt for the greedy, right? In this question, we know that we need to we are asked to maximize the profit. Okay, how much maximum value we can take, and our weight limit is 50. So we can take this much value. So if we take this, since it is lesser than 50, our value, how much value will get? 100. We could have taken this also, but its value is more, right? So we take this. And then our weight becomes 40. And now this 20 is less than 40. We can take this as well. So both the items we have taken, then the weight we have is 30, which is less than 50. So we can hold it, and the profit or the value that we have got is 150. Right? In the second example, the weight limit is 50. And we have 20, 10, 30, total 60. Here it was 30, here it is 60. So it's sure that we can't take all these three with full weight. So in this fractional knapsack, if we can't take a complete object, we can break it and we can take it partially. For example, we can take 30 and 20 and get our answer. That is 100 plus 120. 220. What do we do in greedy algorithm? We take the maximum value thing, right? So 120 plus 100, we get 220. Okay, so is this the right answer? Okay, could we have got more value? Because we can break things, right? So suppose if you would have taken 30 and 10, right? So how much profit you would have got? 120 plus 60, 180. And we have 20 weight. We cut it to 10 because 30 plus 10 is 40. We need 10. 50 minus 40 is 10. 10 kg weight we need. So if we cut it, so 20 kilo weight profit gives is 100. So 10 kilo profit would be 50, right? So 120 plus 60, 180 plus 50, 230. So we have got 230, right? Now 230 is greater than 220. Our greedy algorithm didn't work. We took the maximum values, then we got 120 plus 100, 220, right? And we could not take this one because weight was completed. But here in this case, we took 120 and 60 and took half of it, and we got more weight. Why? Because this 30 kilos weight is 120 doesn't mean its valuation is more than this one. It's 10 kilos weight is 60. That means it's 1 kilo weight is 6. Right? If 10 kilos weight, unitary method, right? If an object's 10 kilo weight is 60 kilo, what is the weight of its 1 kilo? It's 6. In this one, 30 kilos weight is 120. What would be the weight of 1 kilo? 120 by 30. 4. 20 kilo weight is 100. 1 kilo weight would be 100 by 25. So we see that actually this one has more value, right? It's one object's value is more. So we must take this one into consideration first. This should be our greedy approach. So we don't need to sort it according to the value. We need to sort all the objects according to its value divided by its weight. That will give us, we need to take this. So if we do that, then we see that we need to first take this 6 value object. So we took this 10 kilo, right? How much value we had? 60. Next we took 120 by this 5 kilo value. 50 minus 10, 40. 20 is greater than 40. We can take this. So how much weight we have? 60 plus 100, 160. And now 20 plus 10, 30. 50 minus 30 is 20. We have only 20 kilo. And this is 30 kilo. We can't take all of this. So we can take 20 kilo of this. Right? So it's 30 kilos weight is 120. What would be its 20 kilo weight? 120 into 20 by 30, which is 80. So its answer would be 60 plus 100 plus 80, which is 240. So 240 will be its answer. Got it? Okay. So let's code it. How do we code it? We need to sort this item array based on the value by weight of an object. Okay. So we write sort array plus n comparator. This comparator function would be defined according to the value of the object divided by weight. Whichever is more, that would be taken first. Okay. According to this. Okay. Now we have got all the values. So for this example, what would be our value? Say it is weight and value, right? So we take this one first, 10, 60, then 20, 100, which is 5, 6, 5, and then 30, 120 at the end. Okay. Now, once we have done this, then what do? We need maximum value. Okay. We need to return maximum value that we can have when the limit doesn't is 50 kilo for any weight, for any weight here. Okay, so just we'll run the loop for equal to 0 to n, and then what do? If weight of I, and okay, so if array of I dot weight, okay, is less than w, then what do? Weight is less than w, we will just add the value, right? Max value is plus equal to array I dot value, and we will subtract the weight. We have taken this, w is equal to w minus array I dot weight. Got it? And if it is not the case, array I dot weight is not less than w, then what will happen? We will break it into pieces and take it. Okay, so in that case, our max value, what would be our max value? Max value would be max value plus array I dot val into weight, because weight it's weight divided by the array I dot weight, since it is greater. Okay, fine. So here in this case we saw that this one is okay, this one is 30, but we are left with 20 kilos. So array dot val into w by array dot weight, because all the weight would be taken. That's why, right? We had 30 kilo and we can only take 20 kilo. That is the weight that is left actually. So we can break it. We don't need anything, and just we can return the maximum value that we have. Got it? So I hope the explanation is clear how this worked. We do see. I hope this condition you have understand that once we have taken the whole weight, we are reducing the weight here, right? So then we don't need to uh, reduce the weight because we have taken the whole weight already, right? So I hope the explanation is clear. Please try it yourself. The link to the question has been given in the description, and then come to my code walkthrough section. Here is the code walkthrough of the fractional knapsack problem in the Gigs for Gigs platform. So we have this item structure with the value and weight. As we know, we sort this based on the value by weight ratio, and whose value by weight ratio is greater, we will take uh, that weight object. So we have this final value defined. If it is the weight of that object is less than the W, then we increase the final value and we subtract the weight that we need now because we have taken that object's weight. And once we see that any object's weight is actually greater than the weight that we need, then obviously we need to break it from the loop because you would have taken all the weights that is needed from that weight object. That's why we don't need even to make the W as 0. Just get the final value. You have taken all the weights and you take whatever value, how much value you can earn from it, and then just return it. So let's submit this. Okay, so this has been accepted. All the test cases have been passed. Let me know in the comment section how was the explanation, and see you all in the next video where I'll be explaining the 41st question of the problem solving series. Jai Jinendra.